this a little bit bigger, we'll talk about the warm-up. So, please, what two things do you need for a tangent line? Slope and a point, right? We get the point from the original function. In this case, they just gave it to us, right? We get the slope from the derivative, right? So for part A, we know the point is 1/2 1. It was given. So f prime is 24x squared. What was x squared? So f prime of 1/2 would be 24 divided by 4, or 6. Y minus 1 equals 6 times x minus 1/2. Just a little blast from the past. See how well we remember. So, good. Uh-oh. You guys, you gave me an equation of a tangent line of f prime equals 6. Ah, right? You guys gave me the slope, but you didn't give me the equation of the line. So be careful. Make sure you know you're giving me the equation. Good. It's okay. Yeah, just gave me the derivative.
That's right.
You're gonna write that on your AP exam. But do some work on your own, man. All right. You guys solve for slope intercept form. Why did you do that? Why didn't you just write point slope and move on? You like making your life harder? Okay. All right, that's fair. Same thing here. We need to move away from the instinct. Do you know why we need to move away from the instinct? I was actually thinking about, oh, you guys just gave me 6.
Yeah, we didn't really know what to do, so we just gave you the best we could.
Well, you know what? That's hard credits, right? Yeah. So you got, if it's a 2-point problem, if it is, then that's a point. Okay. Point slope form is actually more in line with when you have to find equations of lines moving away from just the xy plane and you have to do it in space. Once you move into space, then and you have to find an equation of a line in 3 dimensions, then it's very similar to point slope form. So the more you get used to point slope form, the easier transitioning into 3 space will be for you. So when you have to write your vector equations of your lines, very similar to this kind of stuff. Actually, I think that it's even easier in 3 space. Use point slope, done. All right. Part B, we had 8 groups in first period. 7 of them got it wrong. So I'm very curious to see how second period did with part B. I don't see a lot of right answers. This was a no calculator question. Yeah. Sorry, I should have mentioned that.
No.
Remember, first 2 questions are calculator. If it's number 3 and on, it's no calculator, right? Unless you're like in the 1990s. Hi, dear. Good morning. All right. So, yeah. Yeah, and you can't leave an answer in trig form like that. The College Board won't accept it. So, guys, I know that I say the College Board accepts unsimplified answers, but not in trig form. You can't leave cosine of pi halves. They won't take it. So you have to evaluate your trig functions. So I don't see a single board with a right answer. Hi, Kasha. So, okay, are you like rejoicing that you beat first period to have the most wrong answers?
Yeah.
Like, woohoo! Okay. All right. Good. All right. Let's walk through it. Now, on a happy note, it looks like almost all of you got a setup correct. So that's good, right? So we are finding the area of R. So our limits are going to go 0 to 1/2. What is the answer to the meaning of life? That's the answer to how many rows a man must walk down before we call him a man. What's the answer to the meaning of life? Top minus bottom. Top minus bottom. So you have two functions, 8x cubed and sine of pi x. Which one is on top? The sine of pi x. So this is sine of pi x minus 8x cubed. Okay, top minus bottom. Is that okay? I see discussion going on.
They're good.
They're good? Okay, good. All right. Antiderivative of sine of pi x. So the antiderivative of sine x is negative cosine x. But as soon as you change that input to not just be an x, you either have to do a u substitution, or if your input is linear, you can just divide by the slope, right? That little shortcut that I taught you that I don't think any of you use, but as life goes on, you might want to use it more. So negative 1 over pi cosine pi x minus 2x to the fourth.
How sine pi x? Yeah.
How is what?
Sine of pi x.
No, the input.
Oh, the input's
The input, yeah. Only if the input's linear. We don't care about the function. So you'd never anti-differentiate, like if your whole function's linear, you would never be doing a u substitution. You just anti-differentiate the terms and be done, right? Okay. All right, so now you get negative 1 over pi times the cosine of pi halves. What's the cosine of pi halves? 0 minus 2 times 1/2 to the fourth minus negative 1 over pi times the cosine of 0, which is 1 minus 0. Okay. And if you left it like that, technically that would be correct. Let's clean it up a little bit. 1/2 to the fourth is 1/16 times 2 is 1/8. So you have negative 1/8 plus 1 over pi. You guys are close. All right. Yes, Casper.
How'd you get the negative 1 over pi? I'm sorry.
No, it's okay. You're talking about this?
Yes.
So if you do a u substitution for, like, say we're anti-differentiating sine pi x, right? Your u would be pi x. So your du would be pi dx. So 1 over pi du equals dx, right? So you'd have 1 over pi sine u. So your answer would be negative 1 over pi cosine u. Right? Okay. All right. Volume. How do we make a profit? Volume. All right. Volume of the solid generated when R is rotated about. Look at how nice they are. They tell you that y equals 1 is a horizontal line, right? Isn't that nice? Yeah. Okay. So, all right. So y equals 1 is a horizontal line, which means we are integrating dy or dx? Dx, because we're revolving about a horizontal line. This is going to be disk or washer? Why washer? Because there's space between your axis and your region that's being revolved. Right? Okay. All right. So volume equals pi integral 0 to 1/2 of something squared minus something squared dx. So we need big R and little r. I wish they would name the region R, right? It's kind of confusing with all the R's, but anyway. So big R, start at the axis of revolution and draw to the farthest away boundaries, right? That's big R, top minus bottom. What's on top for big R? 1 minus, and then what function's on the bottom? 8x cubed. Okay, for little r, again, you start at your axis of revolution and draw to the nearer boundary. What function's on top? And then what's on the bottom? Sine pi x. Now, here's something, just a little note. If your functions have been named, and all you have to do is write a setup, say like you are writing on a whiteboard and you're kind of pressed for not having quite as much space, I could just write this as 1 minus f, and then write this as 1 minus g, right? Because f is 8x cubed and g is sine pi x. So you don't have to put the whole function. If you want to just write the name, you're fine. Right? Okay. Of course, if you have to anti-differentiate, you're going to want the function. It's hard to anti-differentiate. Right?
So how do you know, like, when to use washer this again?
Oh, so whenever your region, so this is our bounded region, right? This is our line that we're revolving about. Is there any space between your region and that line? Any space at all?
Or between? Yeah.
Yeah, I mean, here's my region. There's a whole bunch of space, and there's the line, right?
Okay.
Yeah. So the other thing you could just ask, if you don't like that, if that's troubling you, just ask yourself, is my axis of revolution one of the boundaries of my region? If it's not, it can't be disk. It has to be washer. All right. Good. Oh, did that answer our question? Good. All right. I like that. All right. Any other questions before we move on? All right. I am going to clear this. Goodbye. And let's escape and close. Come on. All right. So before we move into the lesson today, so that was our warm-up. Just in case you're so first of all, we didn't just do parts A and B. We did the whole darn thing, right? So so ignore this. Let's see. How can I cover that up? Let's do this. Let's try 2011 number 3. There. Okay. So before we Okay, 6-2B cross-section. So I am not going to spend a lot of time. There's like 5 slides here. Don't write anything down. But I'm just going to explain a little bit of what's going on. So just in case, if you want your mind blown, all 3 of these shapes are cylinders. Okay? All right. So just so you know, you've like been lied to your whole life. So here's what a cylinder is, right? I'll do it on the board so it goes on the recording. So if you take any graph, whatever the graph is, right? A cylinder is the set of all lines perpendicular to the plane that the graph is in. So if you take all the lines that follow the graph and are perpendicular to that plane, you have just created a cylinder. So, and it can go infinitely in both directions, right? Or it can be a bounded cylinder. But this would be a cylinder. So here we've graphed a rectangle. If I follow along the rectangle, all the lines that come out are a cylinder. Here, this is your standard, right? This would be, if you follow a circle, right? All the lines that come out of that circle, right, form a cylinder. Yes?
What's the difference between a cylinder and a prism?
So a prism is any shape with consistent, what are called consistent cross sections, where all the cross sections, no matter where you slice it, are the same shape, right? So a prism can actually slant, whereas a cylinder has to be perpendicular, right? So a prism could go whoop like that, but a cylinder, so you could say a cylinder is a type of prism, right? Okay. Yeah. Yeah, so So anyway, fun with cylinders, right? When you get into Calc 3, which you're all taking next year, you can have more fun with cylinders, right? Okay. So here's the thing. If we look at this cylinder up here, this is bounded. It has like they've cut it off by two parallel planes. This plane on this base and this plane on this base. But here's your function. This would be like, and it's in 3D, so it's kind of hard to see. But you've got this function. If I want the volume of this whole shape, I take this area of this base. Now for a cylinder, the cross section. Whoa, how did that come up? The cross sections would all be the same shape, right? Just kind of stacked. Pretend that looks good. All right. So anyway, so if you take the area of the cross section and give it a little bit of a thickness, you get this. It's like a really flat cylinder, basically. It's about, just so you know, the volume of anything where the cross sections are consistent is the area of the cross section times the height. So for this one, you take this area of this cross section and you like give it a little thickness. You add all of them together for the whole height of your shape, and you get the volume of the whole figure, right? So what happens for us is we take those thicknesses and make the thickness super small, like approaching 0, and that you essentially just get this flat plane with an area of the cross section. You add infinitely many of those together from A to B, where A to B are the boundaries of your height, and you end up with the volume of the shape, right? So that's volume by cross section is just taking all the cross sections where like A to B, from A to B, you add them all together and you get the volume of the figure, right? Okay, so these next like 18 slides are all just showing you the book's way of demonstrating this, that the cross sections don't have to be like normal shapes. They can be funky, like lima bean shapes or whatever it is, right? So that's okay. So you get this cross section, you give it a little thickness, you add these chunks together, you get your volume. You take the limit as the width of each chunk, don't worry about it, approaches 0, and you end up with this. Okay, so when all is said and done, volume is just the integral of the area of the cross section. If your cross sections are perpendicular to the x-axis, then you are integrating with respect to x with the dx. If your cross sections are perpendicular to the y-axis, then you are integrating dy. That's what we're going to learn how to do. All right, so we're going to do 8 examples. The first 6 are on the next screen, once everyone's got this written. We ready? Anisha, are you ready? All right. Good. So here we go. Example 1. It's really 1 through 6. So the base of a solid is bounded by y equals x squared and y equals 4. So first thing you want to do is just sketch your base. So y equals x squared and y equals 4. That's y equals 4. Now, this is the base. The base is like the bottom of your figure. So you have some base, like in this case, the one I'm holding up right now, the base is a circle, but the cross sections can be any shape. It has nothing to do with the shape of the base. So the figure I'm holding is a solid where the base is a circle, but the cross sections are triangles. And you end up with this kind of a funky shaped figure. And so the width of your circle determines the size of the triangle at that point, right? So on here, the base is like the smartboard. It's this, like the XY plane, and then the shapes are coming out of the board. So you have to picture like a third dimension coming out this way. This is how the shapes are coming out. So the base is on the board, and then the shapes are coming out from the board. So I have one, like I have a bunch of little volumes by cross. This is one where the base is a square, cross sections are semicircles. You get like this kind of a shape, right? Right. So anyway, this one actually kind of works with what we're doing because we're going to do squares perpendicular to the x-axis. Now, this person did y equals sine x. I'm going to ignore that. So ignore this part. Just look at this part. Pretend that this is your parabola, right? Pretend that's your parabola. The squares are perpendicular to the x-axis, coming out of the board this way. Yes. So in this, like for example A, our cross sections are squares perpendicular to the x-axis, so they'd look like that. So as you move along the parabola, right, your size of your square gets bigger. The side of a square, so like one edge of the square is on the plane, and then the rest of the square is coming out from there. All right. Okay. So here's how you do it. So for part A, the first thing I do is I draw a little square. It doesn't have to be anything amazing, just whatever your shape is, just draw it. So I'm going to draw a square. So perpendicular to the x-axis on my figure, I just drew a little line connecting top and bottom because, again, the meaning of life is top minus bottom, right? That line segment will be one of the sides of our square. I tend to always make it on the bottom. So we need to find the length of the side of a square because area of a square is side squared, right? So we need that side length. Top minus bottom. What function's on top? What function's on the bottom? X squared. So the length of this side, whoa, I don't want that. There we go. Is 4 minus x squared. All right. So your volume equals no pi. The reason we had a pi before, when you revolve, whenever you revolve, what shapes are your cross sections? Circles. Area of a circle is pi r squared, right? That's why we're doing all those integrals of pi r squared, because our cross sections were circles. So no pi's for these. It's just whatever the shape is, you find its area. So area of the square is just side squared. So it's just the integral of the area of that square. We need a starting and a stopping point. So since we're dx, we need lowest x value to highest x value. In your groups, take 30 seconds, find those x values. Oh, wow, that was really fast. Okay, what are the x values? -2 to 2. You get it from finding the points of intersection, right? Don't evaluate the integral. Let's just do setups right now. Yes?
Is it always area of the cross section?
It's just area of the cross section. The area of the cross section this is a square. So the area of this square is side squared. Volume is just the integral of the area of the cross section. That's it. All right, we're going to do squares, but now we're going to go perpendicular to the y-axis. When we go perpendicular to the y-axis, now our shapes are going this way, right? So we're going to find this length doing a right minus left kind of a thing. So that line would be that line. But since this is y-axis, perpendicular to the y-axis, now it's a dy. So you can't do like x squared and 4. You have to solve these for x in terms of y. So if this function is normally y equals x squared, you need to find what it would equal if you solved it for x. So if you solve for x, you get plus or minus root y. The right side of your shape is the positive, and the left side of your shape is the negative. Yes. So right minus left, we're going to have root y minus negative root y, which equals 2 root y. So now the side of our square is 2 root y. Right, Costa? Good. Okay, so our volume, oh, whoops, I didn't write my limits on this last one. Negative 2 to 2. So it's still the area of the square, which is 2 root y squared. What are our limits now? 0 to 4. How'd you get those? Low y value to high y value. Yes, Anisha. Okay, so when you're dy, you have to go right minus left, right? So the function on the right, you can't, it has to be solved for x in terms of y. So we took the y equals x squared, solved it for x, right? So you get x equals positive root y and x equals negative root y. When you have positive x's, it's the positive root. When you have negative x's, it's the negative root. So you have root y minus negative root y, which equals 2 root y. Good. Any other questions on part B? You okay?
I got it.
You got it? Yay. Okay, good. All right, part C. All right, let's read this carefully. Isosceles right triangle. It's a big geometry day, just so you know. Isosceles right triangles perpendicular to the y-axis with one leg on the base. So the thing about triangles is they have to tell you, is it, here. Nope, those are squares. This one, okay, this one's kind of funky, but this would be like isosceles with a leg on the base, right? Versus, these look more like equilateral, but pretend they're isosceles and the hypotenuse is on the base, right? So this would be if it was a leg, if it was hypotenuse, it would be like that, right? Okay. So, all right. Perpendicular to the y-axis, so we're still doing right minus left, but now we have to draw an isosceles right triangle where a leg is lying on the base. So this leg of this triangle is now that green line segment. Yes. Oh, like this way? Oh, no, that doesn't matter. Same vibe. Yes, Isha.
Why does it have to be a right angle though?
Because it said it was an isosceles right triangle.
Oh.
Did it not say right?
No, it said it.
Yeah. So isosceles right triangle. Yeah. Okay. All right. So what's this distance right here? It's still 2 root y. And we're still dy, so we're still going 0 to 4. But now our area is the area of this triangle. Everyone in your integral, see if you can figure out the area of this triangle.
There.
There we go.
You're right.
Yes.
How does it work? Where is it on?
It was on a what? So this shape is coming out this way. It's like these are your triangles coming out this way. So like if I here's your triangle. Right? This distance is that distance. Right? And then coming out. We're in 3 dimensions. Yeah. All right. So area of a triangle is 1/2 base times height, but the base and height are the same, right? So you could just square it if you want. So 1/2 times 2 root y times 2 root y, or you could just have 2y, right? If you simplify it. How'd we do? We're good? You ready to try one with a hypotenuse? So part D, isosceles right triangles still perpendicular to the y-axis with the hypotenuse on the base. Dun, dun, dun. So, hypotenuse on the base means your triangle looks like this. The hypotenuse is now your green line segment, which is still 2 root y. We're still in dy mode, so we're still 0 to 4. All right, in your groups, your challenge, find the area of this triangle. 1 is to find the lengths of the 2 legs, because then you could do base and height since they're perpendicular, right? The lengths of the 2 legs would be whatever your hypotenuse is divided by root 2. So you could have 2 root y over root 2, which is the same as root 2 times root y, or root 2y, right? Root 2y for each of these, 1/2 root 2y times root 2y. That would work just fine. I personally tend to go with the other method, which is to drop an to drop an altitude. Because when you drop an altitude, you get these little mini 45, 45, 90 triangles. And now this is a leg and this is a leg, which means the height of this triangle is just half the length of the base. So if the whole base is 2 root y, the height is just root y. So that I tend to do that. You could do whatever you want, right? So anyway, so 1/2 times the base, pretend that's a root y, times the height. Root y. Yeah, so you end up with just the integral of y. All right, another new shape. Equilateral triangles perpendicular to the x-axis. We're back to top minus bottom. We're back to -2 to 2. But now we're going to do equilateral triangles. So I'm going to get you started here. -2 to 2. This is going to be a dx. So since we are top minus bottom, this length right here is not 2 root y, it's 4 minus x squared, because we're back to dx. All right, this is an equilateral triangle. I give you 90 seconds to see if you can figure out the area of this triangle. Begin. If you don't know the formula for the area of an equilateral triangle, you have to figure it out by splitting the triangle into 2 little 30, 60, 90 triangles, right? 30, so this would be your 30 up here, right? This is your 60. 30, 60, 90 triangles have sides of x, 2x, and x root 3. So the height of the triangle is half the base times root 3. So your height, this height, would be 4 minus x squared over 2 times root 3. So your area of your triangle would be 1/2 times the base times the height, which is 1/2 times 4 minus x squared times root 3. And obviously you could clean this up a lot. So just so you know, area of an equilateral triangle is root 3 over 4 times the length of the base. Yeah. But if you don't remember it, you can always figure it out. Root 3 over 4 times the length of the base. Oh, base squared. Sorry. Yes. Yeah, that helps. If you square the base. Otherwise, you're not getting 3 much or 2 much. All right, last one. Semicircles. And then we take a tiny break. A semicircle is a half a circle. Okay, this time again we're perpendicular to the x-axis. So this is still going to be 4 minus x squared. Volume is still going to be integral -2 to 2 of something dx. Volume is the integral of the area of the cross section. You need to find the area of this semicircle. So area of a circle is pi r squared. So area of a semicircle is 1/2 pi r squared. But what's the radius? 4 minus x squared over 2, or 1/2 times 4 minus x squared. Most common mistake is forgetting to square the over 2 part. So this, if you were to clean it up, would actually be 1/8 pi times the radius squared, or times the form of the base squared. So be careful that you square the 2 and not just the 4 minus x squared. Okay. All right, so hopefully you kind of get the gist. We're going to do more examples in a minute, but first, it's Mathematician Monday, and it's time to learn about Terence Tao. Okay. I'm going to freeze this, or I'm just going to... Okay, so there you go. If you're watching the video, I'm just going to let you look at this. You can freeze it right here. I'm moving on. Okay, it is time to get out our calculators. We're going to practice a little bit with calculators, and then we'll call it a day. I want to teach you a little something that you might not have done before on your calculator. So the first thing I want you to do is go ahead and graph the two graphs. Go ahead and graph them separately. 1 plus ln x and x minus 1. You get this shape. We see this shape a lot. To me, I always think of like a banana. So
Another banana problem.
it's another banana. It's another banana problem. I haven't had a calzone in so long. Oh, they're so good.
What is it?
It's like a folded over pizza.
Oh, I had like one.
Yeah. Oh. Okay, what I want you to do is on your calculator, I want you to find the points of intersection, but I want you to make sure that you list both the x and the y for both ordered pairs with a good number of decimals, like at least 6 decimals, however many decimals you can get, right? So for both of these points of intersection, I want you to find them with as many decimals as you can list. Both the x's and the y's. Did you all find numbers roughly like these? Okay. So on your test, there will be at least one problem with like 6 parts. And so we'll give you a shape. Might not look like a banana, but doesn't matter, right? We'll give you some shape, bounded region. And it'll be a calculator question, and you'll have to find the points of intersection. And we might do, part 1 might be find the area. Part 2 might be like find the volume if you rotate that about the line y equals 5, right? Part 3 might be find the volume if you rotate that around x equals 10, right? Part 4 might be find the volume if the cross sections perpendicular to the x-axis are, squares. Part 6 might be find the volume if the cross sections perpendicular to the y-axis are semicircles, right? So we could give you one shape and do a whole bunch of different problems with it, right? No one wants to write 26 decimals 6 times. It's just too much. And the College Board doesn't like it either. So what they like to do is they like to just assign letters to the numbers. So, I don't know. Which one do you want to be a? You tell me. 0.158? 0.158594. Okay, and then B will be, let's do it, negative 0.841406. And then C will be this x value, 3.14619, and D will be 2.14619. All right, on your calculator, there is a beautiful button that you probably don't use very often. I want you on the main window to type 0.158594, and then I want you to hit the store button, which it's like the lower left corner. It says stove. And then I want you to store it to A. So you have to hit alpha, which is like right below your second button, and then find the letter A. It's like a little green letter A somewhere, like above one of the buttons. Did you find stove? And then I want you to do the same thing for B, C, and D. Store all 4 of those numbers. Give each one a letter. Store it to the letter you wrote so that you don't confuse yourself. Okay, so we're going to set up the first problem. So our first shapes are squares perpendicular to the x-axis. Perpendicular to the x-axis, is that going to be a dx or a dy? Dx, top minus bottom. What function's on top? 1 plus ln x minus x minus 1, right? That is the length of the side of your square. Volume is the integral of the area of the square. So it would be 1 plus ln x minus 1 quantity squared. So 1 plus ln x minus 1 quantity squared dx. Now we need our limits. With letters, tell me what our limits are going to be. A to C. I want you to type this on the main window of your calculator using the letters for your limits. Don't type any numbers, just letters. So you just hit alpha A, comma, alpha C, or whatever it is, however you put in your limits. Something around 1.544, 1.545. So yeah. Did anyone not get it? Does anyone need help? Oh, what happened? you didn't square. It's side squared. Guys, if you got 1.949, it means you didn't square your argument. If anyone got 1.949, you're forgetting to put the squared in. Make sure you square it. Anyone else have trouble? All right. Yes. All right. Okay, you only squared the x minus 1. You didn't square the whole thing. You got to move that square out here.
You.
You're going to have to put a new parenthesis. Now try it. Yes, there you go. Very good. Here, wait, let me pause this. Part B, we're going to do rectangles where the height is twice the width and the widths are lying on the base perpendicular to the y-axis. So our widths are going this way, perpendicular to the y-axis. So we're going to find the width of our rectangle, right minus left. And then the height is going to be twice the width. Remember, volume is the integral of the area of that rectangle. However, right minus left means we need to solve these functions for x, right? Because we're now a dy. This one's easy. X equals y plus 1. See, I did that one for you, right? Yeah, you're welcome. Okay, so for this one, I'll even get you started. Y minus 1 equals ln x. I give you 10 seconds to talk in your groups and figure out what x equals.
E to the y.
Oh yeah. E to the.
All right, what does x equal? E to the y minus 1. So right minus left would be 1 plus y plus 1 minus e to the y minus 1. So we're going to have rectangles. Okay, this is right there. So it's y plus 1 minus e to the y minus 1. All right, volume integral of the area of this rectangle, dy. Remember that the height is twice the width. Height is twice the width. So what's the area of this rectangle? Yeah, that times 2 times that, or 2 times that squared. Now, look at your picture, look at your letters, tell me the limits from what to what? B to D. We're going from B to D. And just so you know, on your test and the AP exam, as long as you label what letters your numbers are equal to, you can just use letters all the way through. You should end up with 3.089. No, I always write a fourth so that you know if you were rounding or truncating if you're right. How are we doing with calculators? Okay. You all figured out the store feature? Okay.
Your test is all calculated.
Wait, what? It is?
Yeah,
You're kidding.
I'm not kidding. And just so you know, okay, the next slide we're not going to do. It's to prove the volume of a sphere is 4/3 pi r cubed. We just don't have time.